So, good afternoon, everyone. I'm going to, as usual, start with the introduction. I'm always Teacher Bart, and I normally take students through computer studies right from Form 1 up to Form 4, especially on the key areas that are examined. So today, I'm here to discuss whatever that is called the number systems. That is in a Form 3 topic that is called the data representation. So data representation is a topic that deals with how data is translated or how data is converted from one form to another. So computers, just like human beings, there are languages that they understand, there are other languages that they don't understand. So if it reaches a case where a computer is given any data to process, because as we know, a computer is normally an electronic device that is given some data or some input, the computer will manipulate this input, or it will process these data or inputs under the instructions to give whatever that is called the final information or the output. So the computer must be able to understand the figures. If it is a figure that the computer does not understand, then it is upon the input unit and the CPU to convert these figures into machine language, or a language that the CPU or the computer understands. So this conversion or this interpretation is necessary right from the input. When computer is being given data, it is necessary when the computer is processing this data that it is given, and it is also necessary during the signal transmission, because this transmission and in transmission medium will be done in terms of bits that will be consisting of a given number systems, that is zeros and ones, that we are going to discuss later in this topic. So data representation deals with various number systems. If we talk about number systems, you know what a number means. A number is just like a figure, and these figures, we use them normally to do calculations to get some information. Just like you can be sent to a shop, you are given 100, you are going to buy an item that costs 30. So those are two numbers, 100 and 30. So in that shop, you'll have to confirm that you're given the right change. So there are some maths, or there are some figures that you'll be manipulating to ensure that you confirm that you are given the right balance or other change. So if the item costs 30 and you have 100 shillings, basically through your brain you will do that interpretation and calculation to confirm that the shopkeeper should give you back 70 shillings as change that is derived from subtracting 30 from this 100. So if you talk about the number system, then we are just talking about these numbers. So the number systems that we normally have, there are 4. And this number system, there are situations where, or there are areas where each of them are used. So there are number systems that are interpreted or understood only by humans. There are number systems that are only understood by various machines. But there is something that is called the conversion. So we cannot understand a language, but when you bring in an interpreter, then you can be able to understand whatever somebody from another tribe is saying. What I mean is this: the computer works just like the brain of a human being. So let us take an example in our daily activities. There is a doctor that is working in a certain hospital, and a patient can come from any part of the country or even the world. So you find that you are a doctor and a patient comes in in the consultation room, and this patient, he doesn't understand any other language apart from his local language. So let us say he only understands Kiswahili, but the doctor is a white man that only understands English. So the language that this patient is talking in must be interpreted to the doctor for the doctor to give the right direction. If there is no conversion of that language or interpretation, then it means they will not come into an agreement. They will not understand each other. So that is the basis of these number systems in computing. So what I mean by that example is that even the computer, there is a language that its CPU understands. And the language that the computer understands is called the binary language or the binary number system. The number system or the language that we human beings we understand, that we use in normal calculations like in maths, is called the decimal number system. And there are other machines that also understand the other two number systems that we are going to discuss. So these number systems are discussed under data representation for us to know and to note that the computer understands only a certain number system. So right now, I'm not going to explain in writing, but later on we'll be illustrating something under notes. So you can just take the key points as I speak before we start illustrating in writing. So we have basically 4 number systems that exist. So the first number system that we use in our daily mathematics or calculation is called the decimal number system. It is called the decimal number system. That is the number system that we use in our daily calculations. Like you can just take out your calculator and try to do a certain mathematical operation like subtracting 10 from 20. You will get 10. If you minus 20 minus 10, you will get 10. So that is what we do in our daily activities. So that number system that human beings we understand is normally the decimal number system. We have the second one, which is the binary number system that you want to thoroughly discuss because that is the machine language. So any figure that is entered into a computer as data must be translated into that binary number system because it is the system that the computer will understand. So the major number systems that we have, apart from the other two, we have one is the decimal number system. 2 is the binary number system. The other two that we will discuss, we have a number system that is called the octal number system, and later on also we shall discuss whatever that is called the hexadecimal number system. So you can note the 4 number system. 1 is decimal number system, 2 is binary number system, 3 is octal number system, then 4 we have the hexadecimal number system. So in today's lesson we are going to dwell in the first 2 number system because one of the 2 is what that we use and we understand in our daily activities. So we shall see what they mean. We shall see how we can convert between those 2 number systems, and we shall see why is it necessary that we do all these conversions. So under that part, I'll be able to illustrate as I explain. So let me take this opportunity to take you through the first number system that is called the decimal number system. So these are the 4 number systems. And I want us to start with the first one. That is the decimal number system. So I've said that this is the normal number systems that we all know. And you will be asked in theory to define what it is. So if we talk about the decimal number system, then decimal number system can be referred to as a base 10 number system that is comprising of 10 digits that are ranging from 0 to 9. That is the description of what a decimal number system is. So I've said that it is a base 10, that is the first key point, that is having 10 digits. And these 10 digits, they will be ranging from 0 to 9. So if you count the digits from 0 to 9, you will realize that they are 10. So what I mean is that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are 10 digits. So don't say that they range from 1 to 10. Say they are ranging from 0 to 9. So if you count all these digits, they are 10. So that is what a decimal number system is. So it's only that in maths, you can be calculating a figure like 20 plus 13. So if we say that it is a base 10 number system, then what we mean is that you should denote a radix of 10 to confirm that it is a base 10. So it's only that in maths we don't include the base value, but it's normally there. So this one is a valid decimal number system because it is a base 10, and if you look at the digits that is making this 20, we have digit 2 that is in this range. Digit 2 is here. We have digit 0 that is also here. A number like 13, it is base 10. Digit 1 is here. Digit 3 is here. So it is a base 10 number system that has digits ranging from 0 to 9. So 1 and 3, they are within this range. So you have to include 10 to make it a base 10 number. So back in primary school, I believe that you did something on place values and getting the total value of a number. So that is what will explain a base 10 number. So if you want to get the total value of a number like 1345 or 1345, if you want to get the total value, first you have to know the place value of that number. So this one is under 10 raised to 0, 10 raised to 1, 10 raised to 2, and 10 raised to 3. So this is just like ones. In primary we say this one is ones, this one is tens, this one is 100s, and this one is 1000. So for you to get the total value, you must place each digit under the place value. So each and every digit you will multiply by the place value, then you get the sum of the products of a digit times its place value. So to get the total value, you're going to multiply 1 times 10 raised to 3. Then we multiply 3 times 10 raised to 2, that is this. Then we have 4 times 10 raised to 1, and finally we have 5 times 10 raised to 0. So 10 raised to 0 is just like in ones. This is ones, tens, hundreds, thousands. Then you get the sum of these totals. So this one is 1000 plus 300 plus 40. Any number raised to power 0 is always 1. So we have 5 times 1. That is 5. So to get the total value, here we have 5, here we have 4, here we have 3, here we have 1. So this is how we get the total value of a decimal number. So that one you learnt in primary school. So I was just doing this to explain what is meant by this base 10 number. So in base 10 number, the place values will go up in factors of 10. So you are able to see we have 10 raised to 0, 1, 2, 3. So the place values of each and every digit will go up in factors of 10. So that is a decimal number system. So in summary, a decimal number system is a base 10 number system that is having 10 digits, and these 10 digits, they range from digit 0 to digit 9. So any decimal number must be written with a radix of 10 like this. That is decimal number system. So why are we discussing this decimal number system? So we are discussing the decimal number system for you to understand later this binary number system that is now used by computers. So we will be comparing whether the results that we get from our own interpretation on how we understand the calculations and how the computer will be also getting the result after calculation when using the binary number system. So let us go and do an introduction to the binary number system. So unlike the decimal number system, a binary number system first, it is the machine language. So decimal, I've said it is the human language, so we understand it. A number like 5 plus 2, we understand that it is 7 because we know those figures out of the maths that we do. So binary number system is now a language that is understood by the CPU of a computer, or is understood by these computers or machines. So any figure that you give to your computer, like a calculator is a computer, by the way. So you want to calculate 10 minus 4, which is 6. So you human being is whoever that is understanding these figures, 7 and maybe 4. And the result, you know that it should be 3 when you minus. And that is what will be displayed in the screen of your computer, or in the screen or display of your calculator. But how does computer use the binary number system now to do this calculation that is later on given out as a decimal number system? So that one is what we'll be discussing. So what is this binary number system? A binary number system is a base 2 number system. And I repeat, it is a base 2 number system that is comprising of only 2 digits. And these 2 digits is a 0 or a 1. That is the only description of a binary number system, a system that is understood by the CPU of these electronic machines or these computers. So I've said it is a base 2. Unlike a decimal number system that is a base 10, it is a base 2 number system that is comprising of only 2 digits. And these 2 digits are zeros and ones. So you can see the difference. So in decimal, we said the digits range from 0 to 9. But here in binary, we are seeing there are only 2 digits, 0 to 1, or a 0 and a 1. So I'll explain that one in writing, and we'll be able to see how we convert between these now decimal number systems to the binary number system. So again, in writing, let us look at something a bit before we continue. So let us look at the binary as the second one. This one was the first one. This is the second one. So binary number systems is a base 2. A base 2 number system that has only 2 digits. So we have digits 1 and a 0. So that one means that a binary number will look or would look like this. You can have, so long as you put a base of 2, that one will qualify this as a binary number system. You can have a number like this, 1010110111. So long as it is into base 2, then that one qualifies it as a binary number system. You can have a number like this that is read as 11. If it is in base 10, then this one is not a binary number system. Yes, it is having digit 1, but it is not now a binary number system because of the base value that is 10. So I'm saying that for it to be a binary number, the base must be 2. So in decimal, this one is read as 11. In case it is a decimal number that is base 10, it should be read as 11. But if it is a binary number, base 2, it should be read as 11, not 11. So binary, we only have ones and zeros. So like this number, you should not read it as 1111, but in binary, we read it as 1111. The same to this, we read it as 10101111. So in summary, binary number system is a base 2 number system that has only 2 digits, that is 0 and 1. And I've said that you should stick it into this mind that this binary number system is the computer language. This is the language that the CPU understands. This is whatever that is called the machine language or the 0 and 1 language. So during data transmission, all these signals must be converted into these zeros and ones. Back into our previous example where we said that in a decimal number system, you can have a number like 7 minus 4, which should be 3. So this is decimal number system. You will give this data to the computer. The computer does not understand what 7 is and 4 is. So it is upon the CPU through the input unit to convert this number system that is base 10 back to an equivalent of base 2 number system. Also it will do this to 4 to get another base 2 number system that will be converted back to this decimal number system. So for us to understand that, the next point we will talk about the conversion between those number system. So the first conversion will be between decimal number system to binary number system. So we say that in decimal, an example of a decimal number can be 7. An example of a binary number can be 1011 base 2. So how do we convert a number like 7 into a binary number that consists of zeros and ones? How do we do that? So it is very simple. So long as you've known the bases of each and every number, like I've said that in binary, we have base 2. That one means that the place values of these digits will be going up in factors of 2. We saw that in decimal number system, the place values were going up in factors of 10. Here also we have 10. We also have another 10 here. So in binary, if we have a number like 1011, then the place values will go up in factors of 2. Meaning this one will be 2 raised to 0, 2 raised to 1, 2 raised to 2, and 2 raised to 3. So that is what is meant by the base 2 number system. So how do we convert from decimal number system to binary number system? So the procedure is very simple. take the number, let us say you want to convert 7 into zeros and ones, or 7 into a binary number system. So remember that conversion is done by the computer. So in your calculator, you give it a calculation like this, but now it is upon the machine to convert this 7 and 4, then it will subtract to give a result that will be again converted back into a language that the human you will understand, that is 3. So how do we convert? So take the number that you want to convert. In our example, it is number 7, or we have digit 7. So take that number and divide it by the base value of the number system that you want to convert it to. So the base value is 2. We say that a binary number system is a base 2. So this 2, where is it coming from? The 2 is the value of the base of a binary number system. So we are converting decimal to binary, and binary is base 2. So I'm saying that you take 7, then you divide it by the base value of a binary, that is 2. So as you divide, you will be recording whatever that is called the remainder. So the remainder digits will be either, if it is not 1, it is a 0. So you say 2 goes into 7 how many times? It goes there 3 times. What is the remainder? So the remainder is 1. So 2 goes into 7 thrice, remainder 1. The next step again is to divide by the base value. So you just divide by 2 all through until the remainder becomes the last, until you get the last remainder. So again you say 2 goes into 3 how many times? Once. Remainder 1. Again you divide by 2. So if you reach in this step where now this figure is less than the base value, now you will say that it goes there 0 times, because 2 cannot go into 1, so you say it goes 0 times. Then you record whatever that was here, that is a 1. So you say 2 goes into 1 0 times, remainder 1. I think it's clear. Then for you to get the binary representation of 7, you are going to record this remainder from bottom going upwards. That's why I've placed this 0. So the binary equivalent of 7, you record these remainders. So the remainder is 1, 1, 1. So I've said you record from top to bottom. So we have 1, 1, 1. Then you write it to base 2. So this is the binary equivalent of a decimal number 7. So I think it's clear, but let us do another example. You can be told to convert. Let us now take 9. As a decimal number, you convert it into a binary number. I've said that you take that number 9. Then you divide it by 2 all through. So you say 2 goes into 9 how many times? 4 times. Remember to record the remainder. So it goes there 4 times, remainder 1. Again you take 2 goes into 4 how many times? 2 times, remainder 0. Again you take 2 goes into 2 how many times? Once. Remainder 0. Again you take 2. So I said if you reached here where this one is smaller than the 2, then you will say 2 goes there 0 times, meaning 2 cannot go into 1, so it's 0 times. Then you record that remainder that there is still 1. So 2 goes here 0 times, remainder the same 1, so it is 1. Then finally the binary representation will be a record from the remainder digits from the bottom to the top. So this means that 9 as a decimal number